for soil science. I think that is 4 or what? Just check it now. Maybe actually, maybe that is confused with JSRF and JRF, and they may put kept that. Okay. I will call you after this in class. Okay. Huh? I think it's okay. I will check it once and I will tell you. Okay. Just give me 1 hour. I'm in class. Just class started. Okay. Okay. Bye. Yes. What we discussed in last class? What we discussed in last class?
Nutrient management, sir.
Hmm. Hmm. Yes. చెప్పండి. Why we have to go for site specific nutrient management? What is the problems with your RDF or soil test? Yes. Hmm? Yes. Yes, Achut. Redadu. Then next. Akila. Yes, Akila. Akila also not there. Then ID number 4.
Hello, sir.
There are not ID number 4. Then 4 to 10. Anybody? ఏంటి 10 to 20. 10 to 20. ID number 13.
సార్ చెప్పండి సార్.
చెప్పు. ఏమి ఆర్డిఎఫ్ వల్ల ఏం డిసడ్వాంటేజెస్, సాయిల్ టెస్ట్ వల్ల ఏం డిసడ్వాంటేజెస్, సైట్ స్పెసిఫిక్ మేనేజ్మెంట్ వల్ల ఏం అడ్వాంటేజెస్?
సైట్ స్పెసిఫిక్ వల్ల అయితే మనకు కరెక్ట్ గా తెలుస్తుంది సార్, అక్యురేట్ గా ఎంత దానికి ఎంత ఇవ్వాలి అనేది.
ఎంత ఇవ్వాలని
ఆర్డిఎఫ్ అనేది కొంచెం బల్క్ క్వాంటిటీలో చెప్తారు కాబట్టి.
బల్క్ క్వాంటిటీలో చెప్తారా?
బల్క్ ఏరియా సార్, బల్క్ ఏరియా చెప్తారు కాబట్టి డిసడ్వాంటేజ్ సార్.
ఇంకా
అంతే.
దానివల్ల ఏమవుతుంది?
అవసరం లేని దగ్గర కూడా ఎక్కువ ఫర్టిలైజర్
ఫర్టిలైజర్ వేయడం వల్ల సాయిల్ పాడవుద్ది, దానివల్ల ఎక్కువ డబ్బులు వేస్ట్ అవుతాయి, దానివల్ల ఎక్కువ పొల్యూషన్ అవుద్ది. ఓకే.
Yes, sir.
Okay. Anyhow, these are some of the advantages and disadvantages about your site specific management. There is many advantages in site specific management. Then coming to today's class, while we are giving a fertilizer or nutrient to any crop, any standing crop, you are not considering the need of that particular crop or plant is meaningless. What we are doing, we are simply, okay, even though you are taking a soil sample, do it before the sowing. Based on that, you are applying the crop, applying to the crop. But same time, okay, how much we have to apply? It's based on, it will give your soil test, okay, or whatever the soil test, it will give how much you have to apply. But when you have to apply, when, at what stage? At a single dose or multiple doses? Based on what we will decide, or what will be decide that? Yes, ID number 15, 16, 17. Low. ఇంతమంది కనిపిస్తున్నారు, 58 కనిపిస్తున్నారు. ఎవరు మాట్లాడరా?
సార్
Yeah. When we have to apply nutrients to the crop plant, is it we have to think about this or not? Hello, who is that?
Yes.
Mute yourself. Yes, Gayatri, come up. Hey, mute చేసుకో. ఎవరాలు?
సార్
చెప్పమ్మా గాయత్రి. ఎవరాలు? ఎవరు అన్మ్యూట్
సార్
చేసుకున్నారు?
అంటే హెల్దీ సాయిల్ కావాలన్నప్పుడు
హెల్దీ సాయిల్ ఒకే విషయం వదిలేయమ్మా. ఎప్పుడు వెన్ వీ హ్యావ్ టు అప్లై. ఓకే, హౌ మచ్ వీఆర్ అప్లైడ్, ఆల్ దోస్ థింగ్స్ ఇస్ ఓకే. వెన్ వీ హ్యావ్ టు అప్లై. Okay, I will tell you an example. For a day, as a human being, any man or woman or child or girl or boy, whoever it, generally we are eating like a breakfast we are taking to run our business, then lunch, then dinner. Like that we are divided our meal into 3 or 4 different steps. Like that, when we have to apply fertilizers or nutrients to the crop plant, generally when we will apply, what we call, what are the different type of fertilizer applications? Yes, 17, 18, 19, 20. ఎవరాట ఇంకా టీవీ పెట్టుకుంది వాళ్ళు. ఎస్, when we have to apply, generally we will apply fertilizers at the time of sowing. That is, we call as a, what we call, application of fertilizer along with sowing, or at the time of sowing, what we call, at the time of sowing or before sowing, what we call,
pre-plantum.
Basal.
Then herbicide or pre-plant application and
Basal application.
Yes, Chandra's basal application. Then while if you applying in standing crop,
Top dressing.
huh?
Top dressing.
Crop dressing. So generally we follow this crop dressing, basal application and crop dressing. Okay. But based on what? Based on soil test, we found that there is some deficiencies there in soil. As per the crop total requirement, then we apply something at what time? At the time of sowing or before the sowing. Then next we will apply after some time of the crop in standing crop, that we call as a top dressing. But the top dressing based on what? The top dressing based on the plant's requirement, plant's quick requirement. But how we will determine when that plant required? Based on the experiments, based on research, they are finalized. This is the stage, knee-height stage in maize, then tessering stage in maize is required the second dose or third dose of nutrient. But is it uniformly for every soil, all type of soils in maize crop, or in all type of soils in all locations? No. They are given that is a generalized principle. If you take maize crop, you have to apply it at the time of sowing. What we have to apply sowing again at the time of sowing? We have to apply, suppose 100 kg is recommended, then 50 kg of nitrogen, then full dose of P, and sometimes full dose of K or half dose of K. They are suggesting these are the generalized principles. But that is, we are applied that 50, 100 and 50% NPK at the time of sowing. Then we sow the crop is going on. Then they are suggested that you apply at knee-height stage per maize, knee-height stage, knee-height. Okay, how much? Again, out of the remaining, that is 25% or 1/3% or 25 and 25%. 25, 0, 25. Why? Because your P is applied at the time of sowing only. Then coming to next. Again, they are suggested that at the time of tasseling or silking is the third dose. Based on that, we are applying. But that is generalized, as like your idea. This timing is also generalized. Based on the crop growth stages, there is some generalized phenomena, generalized stages prescribed for particular crop, for particular stage. At particular stage, we have to apply nutrient to get optimum yield. But is it sufficient to get maximum yield? No, it's not. It is not common or uniform for all type of soils. Okay, and all locations. That's why what we have to do, we have to assess the need of that crop nutrient requirement at that particular time. How we will assess? How we will come to know at that time it is feeling hungry or not? You know when you feel hungry. Okay, plant knows when you feel hungry. But how we know that plant feeling hungry and we have to apply nutrients? Yes, we have to know the hungerness of plant, then only we have to apply. Otherwise, it is wealthy and healthy in case of nutrient, then no need. If you applied, if the plant and soil having sufficient nutrients, its stomach, it is fulfilled with whatever the requirement, then again we are applying at knee-high stage. It's the nonsense of nonsense or waste of the resources. For that, to assess the nutrient requirement or nutrient schedule for particular crop, there is a different assessment methodologies or mechanisms is there. Like that, generally the basic thing for identify the nutrient requirement is what is the basic thing? The visual observation of deficiency symptoms on plant. Yeah, tell me any deficiency symptoms in case of maize or paddy.
Kaira.
What is the symptom? That is a disorder, but what is the symptom?
జింక్ డెఫిషియన్సీ ఉన్నప్పుడు సార్ పైన లీవ్స్ ఉంటాయి కదా, లీవ్స్ పైన చివరిలో ఎల్లోగా అయ్యి డ్రైగా అయిపోతాయి సార్.
ఓకే, ఇంకా ఫాస్ఫరస్ కి
purple color.
Purple color. Where we observe the purple color? In which crop mostly?
మేజ్ క్రాప్
Maize generally we observe, not in all other crops, but especially in maize we observe clearly. Then in case of our potassium, K, marginal burnings. Okay, marginal, that whatever that margins of leaf marginal burnings are that one. These are some of the visual symptoms. We will, whenever we observe on field, we have to go for application of nutrients. But this is too late. Maybe it cause some it may cause some yield loss. Before that, any mechanism is there? Yes, there is a mechanism to find the stress, nutrient stress. Here, what is this? Anybody saw before this? This first on this first pictorial, this picture image, there is one instrument, one guy hand hold it with his hand. This, what is this instrument?
Admitter, sir.
Yes. Who is that? నీ పేరేంద్రా?
Manichandra, sir.
ఏంటిది చెప్పు.
Pad meet.
Yes, it says SPAD chlorophyll meter. What is SPAD?
Soil plant analysis development.
Okay, what it did, what it do, for what we will use this? What is the principle here?
Chlorophyll content.
Yes, with this, if you punch on the leaf, then it will use how much chlorophyll is there on that particular leaf. Based on the chlorophyll content, we will estimate the chlorophyll and nitrogen levels have a relation. Which relation? If nitrogen is more, then chlorophyll content also automatically more. That because of that positive relation between that, we'll estimate chlorophyll, and again based on that chlorophyll content, there is a formula. We'll arrive the nutrient requirement at that stage. That plant is required nutrient or not. Like that, we'll take some random samples from the field. Based on that, we'll arrive the requirement. Then we'll go for application of the nutrient. This is SPAD chlorophyll meter. Nowadays, we only using in research stations and laboratories. Means research stage not at reach at a farmer level because it's costly more than 3 lakhs. But if you are using this SPAD waste nutrient management, means it is helps to provide you whenever that plant feels hungry, then only you will provide you are applying the nutrients application, nitrogen. Then it reduces the loss of nitrogen, reduce loss of money, resources, pollution, and all this thing, manpower. Okay, then coming to this, what is this second pictorial? Second this image.
Leaf color chart.
That is third one. Where is cursor moving? Where cursor moving? This one. This is a maize crop. On that instrument itself, they are returned. What is that? Just read out. It's visible or not?
Green seeker.
Green shaker. It's without the here in case of SPAD, we have to punch on leaves, means we have to touch on leaves. But here, without touching the leaves, just it gives NDVI value. What is NDVI? What is NDVI?
Natural difference vegetative index.
Not natural, normalized.
Normalized.
Yes. It gives the chlorophyll content ultimately. Again, we have to relate that chlorophyll, that NDVI value with nitrogen levels, and we have to apply. This is another development, recent development. Okay. Then this third one, just
Leaf color chart.
Leaf color charts. Who developed it first time? Which institute developed it first time? IRI. Okay, what is IRI? IRI. IRRI.
International Rice Research Institute.
Where is it?
Manila.
Philippines.
The IRI developed first time for paddy. Then now it is also developed for other crops. Like your Munson color chart. What is your Munson color chart? Munson or Munson, that is.
Soil.
For what? For what you are using?
Soil.
To find the soil color. Same like that. Here also different what is that? What we call this color charts is there. Where if you go to on field, you can estimate means each level of this color means this has like your value, hue, what is that? Chroma. That indicates the level of the chlorophyll content, means this color has sufficient, this is moderate, this is low, like that indicates. Based on this also we'll estimate. These are the field level handheld devices to estimate on field, on site, and real time. What is that? Real time management of fertilizer or nutrient. We can use with the help of these things. Not only this, there is so many now sophisticated instruments is there available. With the help of this instrument, we can manage nitrogen at real time. Real time means as per the requirement of plants. Not like that way we are applied at knee height stage, it may be taken after 1 week or 10 days, some is going loss, some is going denative for denative, some is for some amount for bleaching, not like that. It is useful for real time management. Then other than this, there is also other mechanisms or other instruments are available to estimate real-time nutrient requirement or plant stress, nutrient stress, that are your drone-based multispectral images sensors or hyperspectral images sensors or satellite-based sensors, maybe multispectral, hyperspectral. Okay, that also we are now, many companies are working on that, doing research for practical or commercialization, practical utilization or commercial utilization. So this is the next future of nutrient management. Now in Western countries already these all are using in at farmer field level, but in Indian condition not yet. Okay. Then okay, this is okay. How much we have to apply? We are decided based on RDF. Then there is another. If you not have any information, then you go as per RDF. Then if possible you go for soil test. If possible you go for grid test, grid soil sampling or site specific nutrient management with your variable rate technology. These are how much to apply and where to apply. How much to apply, where to apply also. Okay, you are in RTA, you are this one, site specific management, where to apply also will consider. Okay, then coming to when to apply, we have to assess the nutrient requirement of the crop plant based on its growth and its need, and it is vary from place to place. For that, having now different type of tools, that may be sprayer, that may be chlorophyll meter, or that may be green shaker or leaf color chart, or maybe drone based sensors or satellite based sensor images to identify stress. Other than that, the basic contour is your visual observation. Okay. Then NDVI. If NDVI is 0.72, then plants look like this. 50% NIR and 8% red. It gives this healthy, like, and NDVI. If your NIR, what is NIR? What is NIR? Right. What is NIR? What is spectrum? Electromagnetic spectrum. ఓయ్ ఏమైందిరా మూగబోయా నోర్లు, లేకపోతే అందరు నిద్రపోతున్నారా మ్యూట్ పెట్టి?
Near infrared reflectance. Near infrared reflectance.
Near infrared reflectance. NIR is near infrared. Infrared. Okay. What is electromagnetic spectrum? Yes. Item number 1, 2, 3, 4. What is electromagnetic spectrum? What you are learning in special technology?
Arrangement of electromagnetic radiations.
What are the different radiations there? What are the different wavelengths is there? TV order? TV order? TV budget? Udileda? చెప్పండి. What is the visible range?
400 to 700, sir. 400 to 700 nanometers.
700 what?
Nanometers, sir.
Then micron? Tell me microns. Tell me in microns.
0.4 to 0.7.
Okay, that is visible. What are they? Then tell me what is the red? Where is the red?
700.
Where is the red?
700 nanometers, sir.
Red. Then which lights are very active replicants, and which is having zero reflection?
Black has zero reflection, sir.
Then which one have black has zero reflection? Then which one have higher reflection?
White, sir.
And what about red?
50 nanometers.
What is RGB?
Green, blue.
Red, green, blue.
In your remote sensing, we are using only this RGB. Okay. And what is NIR? Out of that, red is very effective. So NDVI formula is NIR minus red by NIR plus red. The reflection at these levels. At NIR, this reflection is, if the NIR means near infrared, the reflection is 50%. At red, if it is 8%, then it is healthy plant. NDVI value is around 0.72. If just see next plant, NDVI is 0.14. If NIR 40 or less than that, and red is 30 or more than that, then that is stressed plant. This image, how we will get? With the help of all these things, hyperspectral or multispectral devices, that may be green seeker or your drone based or satellite based. Now the world moving towards this type of nutrient management, real time. Already in Western countries they are using, but in our condition now, some of the companies like Bayer, Coromandel, they are doing research on this type of activities. So there is one basic thing is there in case of nutrient management. What is that? 4 R's of nutrient management. What we call as 4 R's, but I will call 5th R also. This 4 R is given by International Fertilizer Division. They are given this one for the International Society, American Society of Agronomy. 4 R's of nutrient management. What are that 4 R's? Right source, right place, right rate, and right time. And right method also I am adding. Okay. Right source. Which fertilizer you are adding, which source of fertilizer you are adding is very important. You are adding nutrients from FIM or from vermicompost or from inorganic carbon, inorganic fertilizers, or from your through your nitrogen fixation, leguminous crops, or whatever that source is very important. Then within the inorganic fertilizer also, which fertilizer? It is acid forming or neutral or basic. It's a ammonical or nitrate. Okay. It's a can or urea. It's all are important. What is the can? Can. What is the can? Can. What is can?
Calcium ammonium nitrate.
What is its important?
Neutral fertilizer.
Neutral fertilizer. What is the what is that? What are the nutrients present there? What is this one composition?
Calcium, nitrogen.
Yeah, how much nitrogen? How much calcium? How much nitrogen?
25%.
Oh, what is okay? It's neutral. Then what it use? What is the use? If you take any nitrogen fertilizers, maybe that is make increase the acidity. Some ammonical fertilizers increase the acidity, means reduce the pH. Then your neutral fertilizer, nitrate fertilizers increase the pH. Like that. That means increasing the pH above 7.5 or above 8, or decreasing the pH 6.5 or below that also is the problem for availability of nutrients. That's why if we applied can, then it will maintain the soil reaction. Okay, but that is very cost effective and all those things with consideration of that. Now that is the very small in commercial use, small quantity. Can also known as some other names. Can also given as some other names. What is the different other names for can? That calcium ammonium nitrate, farmer fertilizer, kisan khad. Okay, nitrochak something. Also, these are all terms given to farmer fertilizer. Very basic question in many competitive exams they are asking. Which of the following fertilizer is known as a farmer fertilizer or kisan khad? Where calcium ammonium nitrogen. So, like that, source of the nutrient in which source, from which source we are applying, that's also important. Matches fertilizer types to crop needs. Okay, and other than in some cases, in case of tobacco or potato, you are applying merit of potash or tomato. What is what going to happen? Yes, I want to apply merit of potash or potassium chloride to tobacco or potato or tomato crop. Problem?
Leaf burning.
Leaf.
Hey, just give me 1 minute of time. Just I will remove him, and I will not allow him in further classes too. ఇప్పుడు దొరకాలి వాడు నాకు ఎవడు అన్మ్యూట్ చేసుకుంది నేను తప్ప. ఇప్పుడు ఇదే ఆన్లో పెడతా, చెప్తా మళ్ళీ ఒకసారి వస్తే. సో ఎస్, టెల్ మీ. లీవ్ బర్నింగ్, దట్స్ వై we have to choose correct source. We have to go for potassium sulfate. So you got it now, how the source of that nutrient is important. Then next one is your rate, amount, quantity of fertilizer or nutrient also important. It matches amount of fertilizer to crop needs. This what you are applying, it must match, it should match as per crop requirements. It's required 30 kg, you are applying 20 kg, shortage. It's required 10 kg, you are applying 20 kg. It's causing toxic effects, toxicity and pollution of soil water, groundwater and all other these things, and wastage of resources, low productivity is in both cases. Then conduct soil tests regularly in uniform areas less than 25 acres. What we have to do? We have to go for soil test continue regularly. Document crop yield goals based on crop history. You have to document. What you have to document? Yield. What we are discussing geospatial technology. What is that? Yield maps. Then base nutrient application and tri-state recommendations or adaptive management. Nutrient application based on tri-state recommendations are adaptive management using soil test and yield goals or yield maps. Then calibrate nutrient application equipment annually. You have to calibrate your nutrient application equipments. Okay, it's not in our case, in Indian case, not applicable as of now because it's only related to our VRT. Richa, class is going on. Hello, Richa. Okay, I'll call you. Okay. Then, so we have to know which source. Then we have to know how much quantity. Then we have to know when to apply, time. Makes nutrients available when crop needs them. When you will eat food, or when you will take lunch, or when you will take breakfast, when you feel hungry, when you require food for your body maintenance, your what is that, your the metabolic activities to run out your metabolic activities. Same like that, you have to consider in case of plant also. Don't apply phosphorus or forgen or snow covered ground. You don't apply phosphorus or on snow covered grounds. Why? You just go fix. Don't apply phosphorus or nitrogen if a large rainfall is in the weather forecast. Why? Leach out. Okay. Other than this, I told you just before this slide. What I told? Phosphorus you apply at basal dose only. Why?
Slow releasing it.
Slow releasing. Other than that,
Fix it.
if you applied in multiple times, then yes, it's slow releasing, and same time to reduce fixation, if you applied multiple times, the surface area comes contact with this phosphoric fertilizer is increased, then the rate of fixation will increase. That's why you have to apply phosphatic fertilizers. Same time, complex fertilizers. Nowadays, some of the farmers and some of the places, complex fertilizers they are applying in as a basal dose also, or as a standing crop also, top dressing also. But scientifically, we have to apply phosphorus and same time your this also, whatever that, your complex fertilizers at basal dose only. Okay. Then coming to nitrogen. Why we have to apply nitrogen multiple times? Why we have to apply nitrogen multiple times? Phosphorus, if you apply it will go and fix. So for the availability of plant, it will take more time to get available. Then what about nitrogen? Why you have to apply nitrogen multiple times?
Vegetative growth increases.
Other than that, if you apply nitrogen on the field, immediately it will go somewhere and somewhere. Loss. It may be denitrification, leaching, or volatilization, whatever. There is loss is very quick loss. Then plant required every day 100 grams only. But you are applied 50 kg in same day, on same day. In 50 days, how many kgs it's required? 100 grams in 50 days, 100 grams. But you are applied 50 kgs. Where it remaining goes? Is there it fix? No. Nitrogen, is there any fixing mechanism in nitrogen? No, almost. It lost in denitrification process. It leaches out from root surface area, root rhizosphere area. It volatilized due to your photo volatilization or due to sunlight effect. It may run off somewhere due to rainfall and erosion. That's why you have to apply in multiple times based on the plant requirement. And coming to potassium, potassium generally we suggest that 2 splits at least based on the crop. Cotton we are suggest 3 splits. Why potassium? And many of the farmers even now in many of the cases they are not using potassium. Why? Because they think that our soils are very sufficient in potassium. Okay, our soils are moderate to sufficient high in potassium content. But why potassium required for crop? What is the function of potassium?
Disease resistance.
This is grain yield.
Yes, disease resistant, grain yield. What in how grain yield? How? It is provide resistance to disease, resistant to moisture stress, tolerance to moisture stress, resistant tolerance to losing. Other than that, your potassium also called as what? Quality nutrient. Quality. Okay? That's why in case to overcome all these problems, even though your soils are sufficient or moderate, you have to apply at least 2 splits based on the crop. In cotton, we are suggesting 3. Then, but farmers on their own way, they are doing. But wherever you get time, practically or scientifically, you have to suggest these things. If anybody asks you, then utilize variable rate of application, right place of application. Keep nutrients where crop can use them. Utilize variable rate application means your VRT. Then again site specific precision farming. Entire field, if you are applying a nutrient entire field uniformly, it's meaningless. Then that's why you have to apply where it's required. Utilize phosphorus injections, subsurface bonding or broadcasting with immediate incorporation. In our condition, is it possible? It's not possible. Not possible means at present our situation we are not following this. Utilize phosphorus injection in subsurface bonding or broadcasting with immediate incorporation. It will reduce your fixation and increase the availability. Don't broadcast or apply the nutrients without incorporation unless the risk of phosphorus loss is demonstrated to be low. Then what you have to do? Don't go for broadcasting of any nutrients. It may be phosphorus or nitrogen or whatever. Broadcasting, there is no uniformity. There is more loss. Okay, and apply nutrients using minimum setbacks from sensitive areas. Okay, you have to consider all these things. Other than these things, you have to take care about while sowing where you have to place the fertilizer. If you are using your verticum seed drill, fertilizer and seeds both are going same time. So both are applying, sowing and application of fertilizer and sowing of seed is going simultaneously. Then when there is any distance to this both, you have to maintain
5 centimeters.
5 centimeters, sir. 5 centimeters.
3 to 5 centimeters distance between your seed, placement of seed and fertilizer is required. Why? Why? To most of your fertilizers are salts. Okay, it increase once your application of this fertilizer increase salt index. What is salt index? Further that salt content, then that may change the osmoregulation of the seed, osmotic potential of the seed. What is osmotic potential again? What is the osmotic potential? Yes. What is osmotic potential? What is the osmotic potential? Are Manichandra? ID number 25, ID number 13, ID number 2, 1, 60 to 70. Manichandra. Right.
Sir,
Water
Sir.
soil నుంచి plant cells లో plant roots.
చెప్పు ఆస్మాటిక్ పొటెన్షియల్ అంటే ఏంటి?
Water will move from soil to the plant root cells.
Soil to plant, soil to seed. Okay. When it moves from if you take a seed, I am keeping that seed in one solution and water moving into soil seed, inside the seed, means inside the seed coat. Which type of solution that one? There is a 3 type of solution. Not audible. Hyper, hypo, what is it? ISO. This is for your
హైపో అంటే ఎక్కువ వాటర్ ఉంటుంది సార్. హైపోటోనిక్ అంటే ఎక్కువ వాటర్ ఉంటుంది.
ఎక్కువ వాటర్ ఉంటుందా?
హైపోటోనిక్ అంతే సార్.
హైపోటోనిక్
అంటే మోర్ సొల్యూట్స్ ఉంటాయి సార్. హైపోటోనిక్ అంటే మోర్ సొల్యూట్స్ అంటే తక్కువ అని వాటర్ అనే కదా సార్ మీనింగ్.
సొల్యూట్స్ ఉంటాయనా వాటర్ ఉంటుందనా?
హైపోటోనిక్ అంటే మోర్ సొల్యూట్స్
మోర్ వాటర్ లెస్ సొల్యూట్స్ సార్.
అప్పుడు నీళ్ళు ఎక్కడి నుంచి ఎక్కడికి పోతాయి? సీడ్ లో నుంచి దీనికా, దీంట్లో నుంచి సీడ్ కా?
దీనిలో నుంచి సీడ్ సార్.
సీడ్ సొల్యూషన్ టు సీడ్ పోయేదాన్ని ఏమంటారు? అప్పుడు ఏది కాన్సన్ట్రేషన్ ఎక్కువ ఉందని? It moves from low concentration to high concentration or high concentration to low concentration. That is clear first.
high to low, sir.
High concentration to low concentration పోతుందా? Low concentration to high concentration పోతుందా?
హై టు లో.
Concentration.
High to low, sir.
Just check.
కాన్సంట్రేషన్ అయితే లో కాన్సంట్రేషన్ హై కాన్సంట్రేషన్
అయితే
పోతుంది
లో
సార్.
టు హై సార్.
సార్ హై కాన్సంట్రేషన్ వాటర్ టు లో కాన్సంట్రేషన్ వాటర్
ఎప్పుడు ఉంటది
సార్? లో కాన్సంట్రేషన్ అంటే ఎక్కువ వాటర్ ఉంటుంది సార్, సొల్యూట్ తక్కువ ఉంటుంది సార్. అప్పుడు లో కాన్సంట్రేషన్ హై కాన్సంట్రేషన్ పోతుంది సార్.
కాన్సంట్రేషన్ లో హై ఎప్పుడు ఉంటది?
ఎక్కువ సొల్యూట్స్ ఉన్నప్పుడు, తక్కువ వాటర్ ఉన్నప్పుడు. ఎక్కువ సొల్యూట్స్ ఉన్నప్పుడు.
సొల్యూట్స్ ఎక్కువ ఉంటాయా తక్కువ ఉంటాయా?
సొల్యూట్స్ ఎక్కువ ఉంటాయి సార్. హై కాన్సంట్రేషన్.
జనరల్లీ వాటర్ మూవ్స్ ఫ్రమ్ లో టు హై వాట్ కాన్సంట్రేషన్. Antena? Or solutes. Okay. Then potential, what about potential?
పొటెన్షియల్ అయితే హై పొటెన్షియల్ టు లో పొటెన్షియల్ సార్.
And tension?
ప్రెజర్ కూడా అంతే సార్, హై ప్రెజర్ టు లో ప్రెజర్.
Tension.
టెన్షనే సార్.
ఎక్కడి నుంచి హై టు లో నా లో టు హై?
హై టు లో.
టెన్షన్ అయితే లో టు హై సార్.
That two are inversal. Okay. Potential and tension. Is it? Just check it. I have to confirm myself. Okay. Then for that it will increase the concentration, and if you sow nearby, if you apply nearby, it increase the concentration and affect the germination and osmotic, change the osmotic pressure. That's why you have to maintain the distance. Okay. Then again another thing, you may observe in those having a farmer background or those visited farmer field. Sometimes farmer just they are applying on ground, like that, taking fertilizer and applying near the plant on ground. They are just keeping the fertilizer. They shall oppose kuntu potaru mukki. It's also not a correct way. You have to cover, you have to incorporate at appropriate depth and appropriate distance, at appropriate distance and depth, which is better to available for roots. That all things we have to take care. Other than this, next one is right method.
సార్ రైస్ లో అదే ప్యాడీలో సో చేస్తారు కదా సార్, బ్రాడ్కాస్టింగ్ ఫర్టిలైజర్స్, అప్పుడు ఎలా సో అది కవర్ చేస్తాడు సార్?
ప్యాడీలో బ్రాడ్కాస్టింగ్
ఫర్టిలైజర్స్ బ్రాడ్కాస్టింగ్ చేస్తారు కదా సార్, యూరియా, అమోనియా, అప్పుడు ఎలా కవర్ చేస్తారు?
అది ఆల్రెడీ కవర్ అయిపోతుంది. అది ఆల్రెడీ నీళ్ళలోనే వేస్తావు కదా నువ్వు. అది అక్కడ వాట్ యూ హ్యావ్ టు డూ ఇస్ యూ హ్యావ్ టు మెయింటైన్, అంటే ఫస్ట్ మంది వేసే ముందే you have to remove all the water. You only have to keep less than 3 inches of water. తర్వాత నువ్వు దాంట్లో అప్లై ఏదైతే చల్లేస్తావో ఆఫ్టర్ బ్రాడ్కాస్టింగ్, ఆఫ్టర్ 1 or 2 days యూ హ్యావ్ టు అప్లై ద వాటర్. అక్కడ వాటర్లో ఉంటుంది కాబట్టి ఆటోమేటిక్గా అది కిందికి వెళ్ళిపోతుంది. ఇక్కడ ఏంది, నువ్వు అప్లైన్ ఫీల్డ్లో యు ఆర్ జస్ట్ అప్లైయింగ్ on the ground. There is a more choice to loss, and in paddy cases ultimately it's very more loss because of you are applying you are generally broadcasting. Other than that, it's a submerged and anaerobic condition, so ultimately there is a loss is more. There is no choice, but you can go foliar application. You can go foliar application. That's why we are now, due to that all many reasons, now we are again we are opposing. Most of the people, most of the scientific community, or most of the government also is opposing submerged paddy. They are suggesting direct paddy, direct sown DRR, direct sown rice. That is this thing. There is no alternate in paddy. You have to go for other aspects, other alternates only. Submerged paddy having very less efficiency of nitrogen, especially because of all this. Okay. The next one is right method. Which method? Broadcast or placement? Again, which type of placement? Or drilling or foliar spray? The methods of fertilizer application is generally 2 types. What are the 2 types? What is the 2 types? Yes. ID number 9. Fertilizer application 2 types. Methods. Entity. One is solid fertilizer application and another is liquid fertilizer application. That is foliar spray. Okay. Then out of that, again, that is for coming to liquid solid, there is different methods: broadcasting, then placements. Again, placement, the row zone placement, and different placement methods is there. We'll discuss that one. Types of fertilizer we already discussed: organic, inorganic. Okay. Organic, all your manures, fertilizer manures, then bulky, again bulky organic manures and concentrated organic manures. Then your among concentrated your oil cakes, bone meal, fish meal. Then by your in here in case of your bulky, all your FIM compost, vermicompost, all these things. Other than that, your green manuring, all those things. Inorganic, your inorganic fertilizers. Then fertilizers, inorganic fertilizers and or chemical fertilizers. State again it's correspond to state fertilizer. We discussed already urea. Then urea, superphosphate, SSP, and potassium chloride. These are the three basic state fertilizers. These are the three state fertilizers. Then coming to mixed fertilizers, compound fertilizers. This means complex. This fertilizer again classified into complex and compound. Designated blended fertilizers, paste fertilizer or liquid fertilizer also there. Both type of fertilizers there in mixed fertilizer. Yes. Then coming to organic plant fertilizers, that is your oil cakes. Then animal fertilizer, that fish meal, bone meal, dried blood, plus meal, fish, the flash meal, all those things. And animal manure and compost waste of the cows, that cow droppings, manure, cow dung, chicken, all that, and decayed plants and plant material. The state fertilizers and all these things we are already discussed. Anyhow, we go just like that. State fertilizers are those which supply only one nutrient, primary plant nutrient, that is NPK. State nutrients, those which supply only one primary plant nutrient. What are the primary plant nutrient is NPK. Urea, ammonium sulfate, potassium chloride, and potassium sulfate. Okay, your single superphosphate, your potassium chloride, then potassium sulfate, all are these are comes under the state fertilizer. Compound fertilizer. Compound fertilizers contains two or more primary nutrients, out of which two primary nutrients are in chemical combination. Okay, usually produce, that is like DAP, your DAP. Hey, పిచ్చి పిచ్చి కుందరా వెదవా అమ్మాయా అబ్బాయా చెప్తా అర్థం కదా ఒక్కసారి దొరికితే మళ్ళా దెన్ ఆ పొట్ట తీస్తే అక్షరాలను వెదవాళ్ళు ఇట్లా చేస్తారు. Usually produced in granular forms like your DAP, nitrophosphate, ammonium phosphate, all comes under this complex fertilizers. Then coming to mixed fertilizers, physical mixture at farm level, at field level, or at factory level. Our physical mixtures of state fertilizers, this state fertilizer we may mix together physically. In case of complex fertilizer, each granule having all your NPK, or if you take one DAP granule, that single granule itself contain both N and P. But in case of your mixed fertilizers, different. Just you are simply mixing one bag of urea, one bag of KCl, and one bag of SSP together. These are physical mixtures of state fertilizers. They are contains two or three primary plant nutrients made by truly mixing the ingredients either mechanically or manually. This is, you can see NPK 10-26-26, 10-26-26. This fertilizer grade, it indicates what it 10-26-26 means out of 100 kg, 10 kg of N, 26 kg of P, and 26 kg of K. What it indicates exactly. Then components of INM, integrated nutrient management. We already discussed that fertilizers, manures, compost, green manures, okay, crop residues, and biofertilizers. These all are the components to maintain your soil health, to consider with sustainability, to improve the crop production and productivity. You have to go with more than one of this combination of more than one of these components for better management of soil health and plant production. Components, soil sources, appropriate crop variety you have to select, cultural practice you have to follow timely, weed management and intercultivation operations and cropping system, legume based cropping system, like that. Then coming to inorganic sources, super granules, coated urea, super granules we discussed already. Then coated urea, as like sulfur coated urea, neem coated urea, or other coated fertilizers. Okay, it reduces the hydrolysis of that fertilizer, speed of that means a urea action or urea enzyme action or nitrogen enzyme action, that reduce the availability, excess availability, not availability, excess availability, as per excess availability which is not required for plant, and it reduce the loss of the nutrient. Then single superphosphates, muriate of potash and micronutrient fertilizer. These all are inorganic sources. Organic sources, FYM, poultry manure, neem cake, vermicompost, pressed mud cake. Yes, I asked you about pressed mud cake. I asked you a question regarding
Byproduct of sugarcane which is used to reclamation of sodic salts, sir, sugarcane lo.
Yes, good. Then coming to biological sources, microbial inoculates and biofertilizers. These are the different fertilizer sources, the different nutrient sources. Then chemical fertilizers again, phosphatic fertilizer, nitrogen fertilizer, and potassium fertilizer. There are three basic fertilizers. These are the different NPK fertilizers having different composition. In case of ammonium, here out of this, as we discussed, there is a 4 type of nitrogen fertilizer classified into 4 types: ammonical, nitrate, and ammonium nitrate, and amide fertilizers. Out of that, which is more leachable? More leaching properties, more means leaching, more possibility of leaching. Which fertilizer leach more, and which fertilizer volatile more, or which fertilizer more volatile, and which fertilizer are more leachable? Yes. Height number 25, 22.
Sir,
Yeah. Second, I'm in class. Chapo, your nitrate fertilizers leach easily, leach out from root zone. Right. మీ అంతలో మీరు ఒప్పుకుంటారా, లేకపోతే నేనే ఏదైనా యాక్షన్ తీసుకోవాలా? చెప్పండి. ఈ పుట్ట బొమ్మ ఇది ఎవడు? ఎస్, మీ అంతటా మీరు ఒప్పుకుంటారా, నేనే యాక్షన్ తీసుకోవాలా? చెప్పండి. ఏంటి చూస్తారా? నేను మరి రంగంలో దిగితే ఎట్లుంటుందో నా పుట్టబొమ్మ చూపించాలా? సిగ్గు శరం ఉందిరే. చదువుకుంటున్నారు, చదువుకోండి. పుట్టబొమ్మలు ఏంద్రా అందరూ సీరియస్గా ఏదో క్లాస్ వింటుంటే పుట్టలోకి అమ్మేస్తా. నీకు ధైర్యం ఉంటే మీ పేరెంట్స్ వీళ్ళు ఇప్పుడు మాట్లాడతాను నేను ఇదే క్లాస్లో. హలో, I got who is this? Okay. Then ammonical fertilizers are more susceptible for volatilization, and nitrate fertilizers are more susceptible for leaching. Then ammonium nitrate, it contains ammonium and nitrate both, and total nitrogen content of ammonium nitrate is how much? Yes, 34%. Then followed by ammonium sulfate, 21%. Ammonium nitrate urea, 32%. Anhydrous ammonia, the highest nitrogen content Among all nitrogen fertilizers is the ammonium, anhydrous ammonia. But in India, we are not using this. This is in liquid form. You have to inject into the soil. Okay. Then, if you are, there is a given options, highest nitrogen fertilizer containing nitrogen containing fertilizers, and they are not given anhydrous ammonia. Then option is urea. The next, other than anhydrous ammonia, the next option is next highest nitrogen containing fertilizer is urea. Then aqua ammonia 20%, then urea 46%. Then these all are nitrogen containing fertilizer. Then coming to superphosphate. Superphosphate is phosphorus content, P2O5 content is 20 to 46%. Coming to phosphorus, available forms of phosphorus differ based on the soil pH. Sp2O4, H2P2O4, Sp2O4, and P2O4 like that. P2O5 like that. It will acidic soil for acidic and neutral and basic soil. That is will be changes. Forms will be changes. Then superphosphate contains, means here they are given all superphosphates from single to triple superphosphate. Single superphosphate contains 16%, then double 32 and triple whatever that 46. Then monoammonium phosphate. This monoammonium phosphate contains 13% nitrogen and 52% phosphorus. Diammonium phosphate 18 nitrogen and 46 phosphorus. Diammonium phosphate DAP. Then urea ammonium phosphate, that is 28-28-0. Then potassium chloride KCl 0060. K2O content in KCl is 60. Then mono potassium phosphate. Mono potassium phosphate is 0-50-40. 50 P2O5 and 40 K2O. Then potassium nitrate KNO3. 30 nitrogen and 45 K2O. Then potassium sulfate K2SO4 0050 50% K2O. Then out of this, which fertilizer having explosive nature? Explosive nature fertilizer having explosive nature. Which one is explosive? Means it will explode, bomb. Which is more hygroscopic and which is explosive? Your ammonium nitrate is explosive in nature. Then classification of biofertilizers. N2 fixing biofertilizer classified into again three types. Nitrogen fixing biofertilizers classified into three types: free living, Aztobacter, Clostridium, Anabaenae, and Nostoc. Out of this, Clostridium is anaerobic. Then symbiotic. Just a minute. Sanna. క్లాస్ చెప్తున్నామా? తప్పుపడినా అదే చూసిన మెయిల్ పెట్టిన ఇప్పుడే మెయిల్ పెట్టినా. నీది ఎంత పొజిషన్లో ఉంది? 13th లో ఉందా? అదే నేను మొన్న మెయిల్ పెట్టినా, అది వాళ్ళు వాడు దాంట్లో అదే 280 ఏదో నీ తప్పుపడింది కదా, దాన్ని మెయిల్ పెట్టేవాడు ఏం చేయనంటున్నాడు, ఏదో ఏదో వేసేసాడు 220 అని. అదే నాకు చూసుకో, నాకు ఇంతకుముందు వేరే అమ్మాయి నందిని అని వేరే అమ్మాయి ఇదో 19th ర్యాంక్లో ఉంది, అమ్మాయి ఫోన్ చేసి ఇట్లా వచ్చింది సార్ అంటే నేను చూసా. మీరు జాయిన్ అవుతున్నారా నెక్స్ట్ మీరు తర్వాత నేనే ఉన్నా అంటే నాకు డౌట్ వచ్చి నేను చూస్తే అది వాడు 222 ఏదో వేసాడు. చూసా. అది మీరు ఇంకా వదిలేస్తా నేను ఇంకెందుకులే, ఎందుకంటే మనం ఎట్లా జాయిన్ అయ్యేది అదే కదా. అంతే కదా, మధ్యలో చాలా మంది ఉన్నారు మనం అనుకున్న వాళ్ళ కన్నా. ఓపెన్ కానీ అట్లా కాదు కదా, వాళ్ళు కేటగిరీలో ఉన్న కేటగిరీ అంటే బీసీబీలో ఒకటే కేటగిరీ ఉంది కదా. అది కాదు, సీట్ ఉంది కేటగిరీలో బీసీబీ ఒకటే ఉంది, కానీ వాడు ఓపెన్లోనే తీసుకుంటారు కదా, వాళ్ళంతా మెరిట్లో ఉన్నారు. అదే పర్సన్ నన్ను కాల్ చేస్తా, ఒక 10 నిమిషాలు క్లాస్ అయిపోతుంది. ఓకే, సో కమింగ్ బ్యాక్, సో N2 fixing bacteria biofertilizers are free living Azotobacterium, Clostridium, Anabina nostoc, and symbiotic Rhizobium and Anabina azolla. Okay, then coming to here, Azotobacter is a free living aerobic and Clostridium is anaerobic. And coming to symbiotic Rhizobium, symbiotic relationship with our legume crops. Then Anabina and azolla with our blue-green algae. Then associative symbiotic is Azospirillum. It forms association with your jawar, your sorghum, and maize, sugarcane plants. Then coming to here, phosphorus. Before phosphorus solubilizing, here one thing I already told you many times: root nodulizing bacteria, root nodulizing crop, leguminous crops. That is Sesbania rostrata forms roots. Shoot nodulizing, not root. Nodules on shoot as well as root too. And your Rajma, Pasculus vulgaris, it not forms. It's even though a leguminous plant, it not forms your that nodules on roots. It's not fix the biological nitrogen. Then coming to phosphorus solubilizing biofertilizer, that is first one is bacteria. Coming to bacteria, Bacillus subtilis, Pseudomonas satirata. Then coming to fungi is Penicillium species, Aspergillus avamori. These are the fungi species. Then these are phosphorus solubilizing. It solubilize the phosphorus. Solubilize the phosphorus which mixed with as a aluminum phosphate or iron phosphate, and increase the availability to the crop plants. Then coming to phosphorus mobilizing bacteria, Asbescular mycorrhiza, VAM, vascular asbescular mycorrhiza. Second, endo, ecto, and endecto type mycorrhizas is there. It increase the root surface area. It infect, or if it infected with the roots of crop and increase the root surface area, then it is easy to intercept, root intercept or contact the phosphorus fertilizers for uptake, increase the uptake. Mobilize the phosphoric fertilizers near to the root zone. That is VAM, Asbescular mycorrhiza, Plomus species, Scatilospora. Then ectomycorrhiza also there, Lacaria and Bacillus, Blotus, Amenthia. Then ericoid mycorrhiza, Pigilla erica. Then coming to biofertilizer of micronutrients, Silicate and zinc solubilizers is there. Silicate and zinc solubilizers species also there, Bacillus species. Then plant growth promoting mycorrhiza also there, Pseudomonas fluorescensis. Other than this, sulfur solubilizing or sulfur biofertilizer also there. Okay, solubilizing. Then coming to organic manures, what has we discussed? Different organic manures, bulky organic manures, manually derived from animal, plant, and other organic waste and issues, well decomposed animals and other organic residues. That is your FIM format manure, compost from farm and town refuges, and green plant issues, that is green manures, brown manure, dancha, glycidia, and other leguminous crops like cowpea and green gram, black gram. Then concentrated organic manures, oil cakes, non-edible to cattle, mahu cake, neem oil cake, all these things. Then edible oil cakes, mustard oil cake, groundnut oil cake, and blood meal, meat meal, and other excretas. This all comes under this category. Other than this, just we discussed like that sugarcane byproducts, that press mud, then all those things. And then another thing I already told you, that is even inorganic fertilizer, that is steel industry byproduct, that is basic slag. These are the different green manuring crops. Your in situ green for in situ green manuring, leaf green manuring, Cotleria gensea, Sesbania rostrata, cowpea, Sesbania aculata, and cluster bean. These are the different green manuring crops. Then concept of brown manuring. Already we discussed in last class, that is brown manuring. You have to sow the crop, no tillage, herbicide usage, then mulching. Then further it will add the organic matter to the soil. Okay. I will stop here today. We'll continue next class. Just wait. ఏరా డ్రామాలు చేస్తున్నారా? ఎవడిడు? వార్నర్ మామ. మెసేజ్ పెట్టాలనిపించిందా? సిగ్గిసరం అనిపించాలా? ఇంకా క్లాస్ అవుతా అంటే హాయ్ ఫ్రెండ్స్, హలో ఫ్రెండ్స్, బాయ్ ఫ్రెండ్స్ తో రిపోర్ట్ తీస్తే నీ భాగవతం అంతా బయటపడుతుంది. రిపోర్ట్ తీస్తే నువ్వు ఎక్కడ ఏ నెంబర్ నుంచి జాయిన్ అయినావు, ఎక్కడ జాయిన్ అయినా అంత భాగవతం అంతా బయటపడుతుంది. అర్థమైందా? మీ నాన్న దగ్గర డబ్బులు ఎక్కువ ఉన్నాయండి, చదువుకోక ఇట్లాంటి పిచ్చి పనులు చేయమన్నాడా? ఒకసారి మీ నాన్నతో మాట్లాడచ్చు, చెప్తా నేను అప్పుడు. మీ నాన్న అదే మా వాడికి చదువు అవసరం లేదంటే చెప్తా. మనిషికి కొంచెం ఏదైనా అనిపించాలా, నాన్ సెన్స్ అండ్ ఆల్. అంత డబ్బులు ఎక్కువ ఉంటే బిజినెస్లు పెట్టుకుంటారా ఊర్లో? డబ్బులు 4 సంవత్సరాలు అందుకే ఇది వేస్ట్ చేస్తారు. మీ నాన్న ఇది ఆయన ఏదో కష్టపడి సంపాదించుంటాడు. పిచ్చి పిచ్చి చేసా లేదు క్లాస్లో. మూడు సంవత్సరాలు అయిపోయింది. 3 సంవత్సరాలు నేర్చుకుంది. ఒక్క గంట సేపు పాఠం చెప్పు ఏదైనా ఒకటి. నీకు తెలిసింది ఏదైనా టాపిక్. పిచ్చి వేదవాళ్ళు. చదువుకునే వయసు, చదువుకొని చక్కగా అయితే బాగుపడతారు. రేపు ఏమన్నా మంచి సమాజంలో, సొసైటీలో ఎవరైనా వాడు రెస్పెక్ట్ ఇస్తాడు. లేకపోతే పెళ్లి చేసుకోండి పిల్లని కూడా ఏడవాడు. ఇవాళ రేపు డబ్బులు లక్షలు ఉన్నాయి, వాడు చేయట్లేదు పిల్లని. చదువుకోండి, ఫస్ట్ చదువుకోండి బుద్ధిగా. ఈ పిచ్చి చేసేయాలని వేయదు అక్కరాని పనులు. ఇంకోటి ఆల్రెడీ మొన్న కూడా చెప్పాను, మీరు ఇంతకుముందు ఏ డ్రామాలు వేస్తే, ఎట్లా డ్యాన్స్ చేస్తే అట్లా మేనేజ్మెంట్ కానీ కాలేజీలో కానీ ఒప్పుకున్నారు. ఇప్పుడు ఒప్పుకునే సిచ్యువేషన్ లేదు, అలా అస్సలు టాలరేట్ కూడా చేయరు. ఓకే, ఒకసారి చూసి రెండోసారి చూసి ఇంటికి తీసి ఇచ్చి పంపిస్తారు. నువ్వు చెప్పినవులే అని అనుకుంటే ఇంకా నీ కర్మ. ఇప్పుడు సిచ్యువేషన్ వేరు, ఇప్పుడు సిచ్యువేషన్ మారింది. అండ్ దేర్ ఇస్ ఎ డిసిప్లినరీ కమిటీ ఆల్సో ఫార్మ్డ్ ఇన్ కాలేజ్ రిగార్డింగ్ యువర్స్ డిసిప్లిన్. ఎస్, అటెండెన్స్. Okay, 2016 batch. Anybody? 16 batch, all are absent. Then 17 batch. 17 batch, anybody? Oh, sorry, I will unmute.
Sir, 37 present, sir.
సిగ్గు శరం లేదురా, వెదవన్నారా వెదవ, ఎన్నిసార్లు తిట్టాలి నేను? Go out of my class and don't come to any of my class in this entire semester. Just you leave, otherwise I will take appropriate action on all the students. Yes, 2016?
13, yes, sir.
16, 13.
Yes, sir.
Yes. Video, audio. What?
2016 batch 33, sir.
Okay. Next. Next. Nobody in 16? Okay, 17?
16 batch 33, sir.
అయిపోయిందమ్మా. నెక్స్ట్
17 batch 15, sir.
15. 15
Yes, sir.
ఎక్కడ కనిపించట్లేదు నువ్వు? వీడియో ఆన్ చేయి.
37, sir.
ఆగండి, వాడు చెప్పినాక ఎవరే 15 17? 17 బ్యాచ్ 15 ఎవరు?
17 37, sir.
నరసింహ సార్.
ఎక్కడ ఉన్నావు నువ్వు? వీడియో ఆన్ చేయి. వీడియో ఆన్ చేయి. ఏమి? ఎనీబడి 2017 batch 1 to 20? 1 to 20, anybody? 1 to 20 all are absent. Then 21 to
15 present, sir.
ఎవరు?
15, sir. నేనే సార్.
వీడియో ఆన్ చేయి మరి. వీడియో ఆన్ చేయడం ఏం ప్రాబ్లం? ఎక్కడ బయట ఆడుకుంటున్నావా? క్రికెట్ గ్రౌండ్ లో ఉన్నావా?
ఇంట్లో ఉన్నా సార్.
పెట్టు, వీడియో ఆన్ చేయి.
ఆన్ చేసే సార్.
ఎక్కడ కనిపిస్తున్నారు బాయ్ నాకు? ఆన్ చేసి నాకేం కనిపించట్లేదు.
చేసే సార్, చూడండి సార్.
ఇప్పుడు చేయి.
ఆన్ చేసే సార్, చూడండి సార్. ఆన్ చేసాను సార్.
లక్ష్మీ నరసింహ అని వీడియో అయితే బొమ్మ అయితే కనిపించట్లేదు కానీ ఓకే. నెక్స్ట్ ఆఫ్టర్ 50, ఆఫ్టర్ 15. ఎనీబడి?
21 present, sir.
ఎక్కడమ్మా నువ్వు? ఏం పేరు?
Manjusha, sir.
ఓకే, నెక్స్ట్. నెక్స్ట్. నోబడి ఆఫ్టర్ 21, అప్ టు 40? 21 to 40.
17 37, sir.
ఎంత?
17 37.
17 37 అని 37 అని చెప్పి 17 బ్యాచ్. సరే, నెక్స్ట్ ఎక్కడ ఉన్నావు? ఏం పేరు? నీ పేరు ఏం పేరు? 37. 17 బ్యాచ్ 37 పేరు. ఓకే, దెన్ ఆఫ్టర్ 37, ఆఫ్టర్ 37 to 60, 2017.
47, sir.
47. నేమ్?
47, sir.
నేమ్?
Umima, sir.
ఓకే.
51, sir.
నేమ్?
Srihari.
ఓకే, ఆఫ్టర్ దట్?
Present,
ఏం ఉజ్వల?
sir. 56,
ఏమన్నా మాట నీకన్నా అర్థం అవుతుందా? నువ్వు మాట్లాడేది నీకన్నా ఇది అర్థం అవుతుందా?
56, sir.
ఉండొచ్చు కదా, నెట్వర్క్ వచ్చే దగ్గర కూర్చోవచ్చు కదా. దెన్ ఆఫ్టర్ 57?
Sir, 56, sir.
ఎవరు? తేజశ్రీ. ఓకే, నెక్స్ట్. ఎనీబడి?
సార్ 70, సార్.
ఎన్నిసార్లు పిలవాలి మరి నెక్స్ట్ అని?
70, సార్.
ఎన్నిసార్లు పిలవాలంట నేను? Next. Okay.
అంటే నా ముందే ఇద్దరు రా.
Okay, sir. Anybody remaining? 15, 21, 37, 47, 51, 57, 56, 70. Okay, that's all. Okay. Then 2016 batch. Only 13 and 33. That's all. Okay. 16 and 17 you leave. 16 and 17 batch students may leave now immediately. Yes. Only 18 batch is there. Yes. 72. 72.
Present, sir.
ఏం పల్లవి?
Present, sir.
3 క్లాసులకు ఫస్ట్ క్లాస్ వచ్చావు?
Sir?
3వ క్లాస్ లో ఇవాళ నువ్వు ఫస్ట్ వచ్చావు.
No, sir. Second.
మరి ఏంటి ఎస్ ఏంటిది? మొన్న వచ్చావా? మన క్లాస్కి రాలా, అంతకుముందు జియో స్పెషల్కి రాలా. ఓకే. నెక్స్ట్ 71 నాట్ దేర్. 70.
Yes, sir.
అరే కవిరాజు క్లాస్లో ఉన్నారా?